All right, so today is Wednesday, April 1st, 2020, and this is CS 372. And it's April Fool's Day, and I think the fool is that it's snowing out again, which is like, what the hell? Emily, are you playing fetch with your cat? Okay, is that a roommate in the background? I can't hear you. Okay, hi, Emily's roommates and cat. Okay, let's see here. So I'm going to go ahead and bring up VS Code because that's what we're doing. Let's go with code. Boop. Okay. And it'll take a couple seconds to boot this thing up, but the cat's name is Ellie. It's adorable. Okay. So I'm going to bring us back to where we were. Unfortunately, I did lose that stuff that I had saved, so I had to go and rewrite the notes, which is my dumb fault. But we were working on a vending machine, if you don't remember. So I'm going to go ahead and boot that up here, and let's go ahead and share it. So I'm going to click on the share button, and I'm going to share my desktop. Okay. So this is where we were at, and now remember it's Alt D in order to. I suppose I should be in the right window. It's Alt D in order to generate a new copy of our vending machine. This is where we left off. Okay. So I'm using, once again, I'm using plantUML. It seems to be working really well for me, at least, and I think most of you like it better than starUML. So let's go ahead and continue on with this. So you can see here, our vending machine. We have three different use cases. We have the customer interacting by buying the beverage. Now, buy beverage, of course, has a bunch of sub use cases within it, right? There's when the customer's buying the beverage, there's a few different things that might happen, and we had discussed that. I wrote that out, but there were a few different things that might happen. You might have it that the customer just gets the drink and is happy and goes home, gets his card back or whatever change there might be. You have it where there's insufficient funds or the customer has inserted the wrong amount of money, and so the what'll happen there is the machine will spit the money back out of them and tell them that they messed up. And the other option is that it is out of stock, which means that somebody needs to restock it. So in this instance, all that's going to be covered under the buy beverage use case. Okay. Now we also have the employee. Okay. Now the employee can do one of two things. They can either restock the machine or they can collect the cash. Those are the two use cases that the employee has to be concerned with. Okay. Now, we're not quite done yet. Hold on a sec. I'm just getting things organized. Okay. We're not quite done yet. Hold on a sec. Okay. So when we're talking about use case diagrams like this, we have a couple of instances that are called dependencies, right? So when the employee is restocking the machine, and I think we kind of left off at this, when the employee is restocking the machine, they need to, by default, include some kind of sub process. Okay, so when the employee restocks the machine, what do they have to do? What's the first thing that they have to do when they restock the machine?
make sure they have access to the machine, like the keys to refill it?
Yeah, so let's just skip right ahead and say that they have to have their keys and they have to be able to open it, right? So that would be something that the employee would need to be able to do. Okay. So in order to restock the machine, the employee first has to unlock the machine to open it. Does that make sense? So what we're going to do here is we're going to declare a relationship. Okay, so I'm going to declare a relationship between the two states. We're going to have a state called restock machine. We already have that. That state is going to be dependent upon uh, the machine being unlocked. Okay, so those are you have to unlock the machine before you can restock the machine. Does that make sense? So I'm going to put in another use case. I'm going to call it unlock machine, and the restock the machine is going to be dependent upon the machine being unlocked. So I'm going to do a left arrow and 2 dots, and this denotes that there is a relationship. Oh, I spelled unlock wrong, and I put unlock in there twice. Wow. I should put, how about restock machine? There we go. All right, back it out here. Whoops, gonna have to re-render that. Alt D to re-render. Okay, cool. So what we have here, this arrow that is dashing over to where it says unlock machine, okay, that is a relationship. Now there are really kind of 3 different relationships that we can have in use cases. Okay, so I'm just going to go over those with you really quick. So the different relationships within use cases, I can screen share, bring up the whiteboard. So the 3 so these are relationships in use cases. And those are, first of all, we have inclusion. So, inclusion. And inclusion is the reuse of a use case action within another use case. Okay, so that is inclusion. And that's what we're going to be doing here with our vending machine. So with our restock machine, in order to restock the machine, we need to include unlocking the machine. So it's a dependency. So in order to denote that we're going to include unlocking the machine inside the use case of restocking the machine, we need to add what is called a stereotype. Okay. Now, a stereotype is essentially something that extends a use case. Okay, it extends a use case. It's something that's not necessarily built into UML. So include, and the way that these are denoted is by chevrons. So you have 2 chevrons and include. Oops. And so to do that, to get that in plantUML, you just put a colon. So colon, chevron, include, and chevron. All right, does that make sense? I can't, let's see here. Ugh. I can't see whether or not you guys, so you'll have to like say it in the chat if it makes sense to you, or if it doesn't make sense. Yeah, makes sense. Okay.
I'm a bit confused. Like, is the UML supposed to have those chevrons there,
Um,
or is the chevron supposed to do something?
so it is a little bit confusing. So just think about it this way. You know how you can overload a method in object-oriented
Yeah.
programming? Yeah, just think of it as like overloading a method, right? Um, so restock the machine. Um, it doesn't come with the how do I put this? Restock the machine does not come with the method unlock machine. We override it, or sorry, overload it using include. And so I'm really explaining this poorly. Uh, so a stereotype is a fancy word for custom action. There we go. And the apparently the phrase include is not a standard action within unified markup language, if that makes sense.
Okay.
Okay, so just um, that's what that denotes. Okay. Okay. So we're going to include unlock machine. So in order to restock the machine, we include unlock the machine. All right. So we have that, but also in order to, once you're done, I guess, restocking the machine, then what do you need to do?
Lock it.
Lock it. Yeah, exactly. So we need to then lock the machine. So we've got unlock the machine, restock the machine. Let's go ahead and lock the machine. So, oops, lock machine. And then this is an action that is included. Okay, so lock the machine is an action that is included in restocking the machine. Okay, so we've got unlock machine and lock machine. Now, we're going to do the same thing with collect cache, right? Because if the employee is going to collect the cache, they need to unlock the machine, but they also need to lock the machine. So we need to do the same thing again, but we're going to do it with our uh, unlock and lock with collect cache. So let's do that. So unlock machine and collect cache. And that's another include. And then unlock machine. And oops, I didn't mean to put 3 dots there, 2 dots. And oh, I already did that one. Sorry. Lock machine, not unlock machine. And collect
What about the space before
cache.
the dots?
Thanks, Hayden. I need that. There we go. Live coding, not even once. Okay, so there you go. So somebody's going to ask, does it matter which way the dot dots and the arrows are facing? No, it doesn't matter which way the dot dots and the arrows are facing. You could very well easily do this. You can get rid of lock machine, remove that, and then we could put that on the other side, and then we just have to reverse the direction of the arrows. So of course it generates a bit of a different looking little plotty plot here. There we go. Yeah. So as long as the dependencies are, did I put that the wrong way? I did put, no, collect cache includes lock machine. Yeah. So really what you're changing, all you're doing by changing the order in which these individual use cases are is you are changing the layout. So which ones appear first, which ones appear second. I prefer it the other way around, but you could always have it look like this too. So collect cache includes unlock machine, collect cache includes lock machine, restock machine includes lock machine, and restock machine includes unlock machine. And the customer just buys the beverage. Does that make sense?
Yes.
Okay, good. All right, so this is inclusion. Okay, so that's one. It's just one of the. That's just one of the different ways. You know what? I wonder. No, I'm gonna leave it this way. That's just one of the different ways that we can show relationships between different use cases. There are a couple of others, and so another one. So you have inclusion relationship. Another relationship would be a extension relationship. And an extension relationship is an additional behavior that is performed under certain conditions. Okay, so that's an extension relationship. And so you're probably familiar with that phrase in object-oriented programming. So an extension, for example, that you might have in this instance would be, say that the customer wound up, I don't know, needing assistance with the vending machine, and this is a very fancy place, and they have little people that, like, you press the help button and they come out and they help you. I'm just making this up, but anyhow, you might
Is that like
have,
Oompa Loompas?
yeah, I didn't want to say Oompa Loompas, but yeah, you have Oompa Loompas that come out and help you, and they say Oompa Loompa, doopity ween, I'm here to help you with the vending machine. I'm sorry, it's been a long week. Okay, anywho.
Ween?
Yeah, Oompa Loompa, doompity ween. I'm here to help you with the vending machine, because it rhymes. That's all I could think about. You know what? Just go away. Okay, so what we want to do is when the customer comes up with this problem, we can extend buying beverage. We can extend the buy beverage use case. And the way to do that is, so I'm going to go buy beverage. And that is extended by help. And so you can see here, you've got buy beverage and buy beverage. Help extends buy beverage. Okay, does that make sense? Now, one neat little thing that you can do, if you are kind of obsessive compulsive, you can change the length of these arrows by adding as many dots as you want. So I can make help go really far away if I wanted to. Yeah, see that? So help is on the way, but it's a long ways away. But I'm going to have it be really close to buy beverage. All right. So, use case diagrams. Questions about those? No? Okay. So the last, I guess, not dependency, the last relationship that you can define, and we've already kind of done this, so I'm not going to really get into it, but I will write it down here just for consistency's sake. But the last one is, of course, inheritance. So inheritance. Okay, and so inheritance is inheriting the behavior of a parent. Oh boy, I spelled that the English way. Behavior or the Canadian way. Behavior and so inheritance is inheriting the behavior and properties. Oops. Gosh darn it. Of the parent. And so you're all familiar with, of course, inheritance when it comes to object-oriented design. I don't think I need to rehash that much or at all. So inheritance. Damn Americans. Yeah. Well, you know what? We get rid of the extra junk that you don't need. Okay. That's why we had a tea party. Questions about use cases? No. Okay. Cool. Now the last one that I'm going to go into in detail with UML, and I'm obviously we don't have time for me to go through every single different type of UML diagram that's possible, right? Because there were a ton of 10 major ones that we identified. And Emily, Americans don't spell Q that way. We spell it this way. Okay. Anyhow, so, and we also don't say Q. We don't say like Q up in the line. Anywho, so I'm not going to go through all of those. Right, I'm not going to go through all of them. We went through. This would be the. We went through. Let's see. It was the first thing I showed you was the. What was the first one? Remind me. What was the first one? What was the first type of diagram that we went through here? That we diagrammed out together. Using plantUML. Yeah, Emily's getting it. Sequence, yes. So we did sequence diagrams first. So the first thing that we did was we went through and did a sequence diagram. Talked about use case diagrams. I showed you a way that you can to list out the proper way to list out to follow the object-oriented approach and to list out the initiating actors, preconditions, and scenarios. And now we're going to move on. The last one that I'd like to talk about before we go into Petri nets, which will be on Monday. We'll talk about it in class. I do think I'll probably have to release a couple of videos in the meantime in order to catch you up with what you'll need to know. But we'll see. But we'll go and we'll talk about now. Move on to class diagrams, because class diagrams are probably the most important as programmers for you to know about, other than use cases and sequence diagrams. I think if you know sequence diagrams, use case diagrams, and class diagrams, then you should be pretty good. Okay. So let's go ahead and dive right into that. So class diagrams. Now class diagrams show the structure of a system. And I'll bring up the whiteboard here. So let's go ahead and talk about class diagrams. So I'm going to draw class diagrams. And class diagrams, they serve to show the structure of a system. And class diagrams also show the data, visibilities, control, and relationships between objects. All right. So what a class diagram? So the base class of a class diagram, I'll call that the archetypal class. The archetypal class of a class diagram looks something like this. So if you're going to draw out a class diagram, it's usually a box for the element. So we're going to talk about an individual class right now. So you have a box, and then within that box, you have some partitions. So we have a partition up top here, and the first partition, this is going to contain the class name. So that's the top partition. That will contain the class name. And that goes up top. Boop. Okay. And then underneath the class name, you have a list of the class attributes. So these are attributes. And then you have the operations. And finally, at the very end, you have the responsibilities. Oops, responsibilities. And these are all partitioned off as well. So I'm going to draw a little partition between them. If I can do that, that'd be cool. There you go. So attributes separated by the operations, and operations are separated by, there we go. Cool. All right. So this is what a class diagram will look like for an individual class. Now, of course, classes are related to one another, and you have instances of them. We'll get into that a little bit, but the basics of this. So first of all, you have the class name. And the class name will be something like, I'll show you in a moment. I'm going to use an example of a student. So the student will be, the class will be student. Now the attributes describe a range of values. So these attributes here, they describe a range of values, including what strings are needed, what reals, ints, booleans, etc. are needed. Okay, and it tells you what the default values of each of these are. And now we're talking about classes as in programming right here. Of course, you can extend this to any kind of system analysis, but strings, reals, ints, bools, etc. And it gives the default values for those. Okay, so that's attributes. So I can write that down if you like. Is there an arrow? There is an arrow. Cool. Zoop. So our attributes, they describe values, strings, ints, bools, etc., and give default values. I haven't turned the stamps off, so thank you, whomever did that. Okay, I haven't turned, never mind. Come on, let's get this guy. Bools, there we go. Cool. Oh no, I have two parentheses and one's not closed. That's a syntax error. Oh well, whatever. Okay, so the other one here, we have the list of operations that we can perform. And the operations that we can perform are, actually, just write this, gives prototype of operations. So this will be where you detail what methods, right, what methods a class has attributed to it. So gives the prototype of operations. And then the third one down here, this is responsibilities. And the responsibilities, boop. And the responsibilities tells you what the class does. Okay, so it tells you what the class does and what it's responsible for. So attributes, operations, and responsibilities. Okay, so before we do too much else, let's go ahead and try to just implement a really rudimentary class. So I just want to show you exactly how this works. 1 second. I'm gonna bring up my other notes here. Whoop. Oh, come on. All right, so I'm gonna close out of this. And then I'm going to share this guy. So I'll share with this desktop. All right. Okay, so I'm gonna go ahead and create a new file. We're gonna start a new file here. And I'm going to call this student.plantUML. Okay, I'm gonna close out of the vending machine. Whoops. Okay, there we go. All right, student.plantUML. Now what I want to do is I'm going to create a class called student. And the goal here, the long-term goal here is going to be, to allow, we're building like a registration system for a school. Okay, something like that. I know it's a boring example, but just roll with it. Okay, so to begin, I'm going to begin the way we began before. I'm going to go at start UML, and I'm going to call this student. Okay. All right. Now, in order to define a new class, what we can do is we can go class student. And now we have a class called student. I'm going to go ahead and, oops. What do you mean no start UML found? It's right there, you dingus. I suppose I need an end UML though. Okay. There we go. All right, so that's pretty boring, but hey, it's something. Now, what I'm going to do is the first thing that we need to do. We've defined the class name, so you can see right here where it says student. Where it says student, that's our class name. Okay, so that's the first box. Now, the second box that we're going to next create is going to be the box that lists out the different attributes. So what would be some attributes that a student might have?
User ID.
Yes, like a student ID. Student ID. And student ID, what type of data is a student ID?
Int.
Yeah, an int, or when I was as an undergraduate, I had our student IDs all had a W in front of them, so it's like W302519, something like that. So what might be a better way of
The string.
the string? Yeah, so I'm going to call it a string. Okay. Whoops. Not whatever the hell that is. All right. So what's another thing that it might be good to identify a student with?
Name.
Their name. And no, Emily, we're not gonna put their sin in there. But yeah, it's, I guess. See here. So let's go with their name. So I'm gonna go first name. So first name, and that's usually what?
String.
String.
Yeah. Okay. And then if you got a first name, you should also have a
Last name.
Emily's over there. Credit card number. I see you, Emily. All right. So I got first name, last name, student ID. What's another good thing to know about a student?
Address.
Their address. Sure, we can do that. So address. That'll be another string. Date of birth. Yeah. So a DOB. And the DOB will be a date. Let's assume that date is a primitive. So a DOB will be a date. Okay. Now, when it comes to different objects inside of, or different, sorry, when it comes to different properties, I mean different attributes inside a class, one thing that's usually important is that we know what type of permissions, right? What type of permissions what has when dealing with those classes. So, for example, you might have a public string, or you might have a private string, or you might have a protected string. Okay, we can actually denote this. This is kind of fun. So, for data encapsulation, the first name, last name, student ID, address, and date of birth, these are probably all best to be private as opposed to public, right? So these will be accessible only by this class. So to denote that they're private, what I do is I put a minus out in front of them. So I'm going to have all of these be private. There you go. So not all of those are denoted as private. Okay. Questions about that?
Public is a plus.
Yes, public is a plus, and we'll get to that in a moment. So, of course, public is the next thing we're going to do. Public is our methods or pieces of data that are directly accessible by other classes. Okay. So, for example, if you want to get the date, if you want to get the first name of a student, you might want to declare an operation or a method that does this and make it public. So, next thing I'm going to do, set first name, and that's going to be a string, and make that a void so it doesn't take anything or doesn't return anything. And then let's go ahead and set last name. It'll take a string, and I'll return a void, and then set student ID, and then set dob. There you go. Now you see the ones that are public now have little green circles next to them, denoting that they are public. Cool. Does that make sense? Yeah. And then finally,
you want to set the address as well?
Oh yeah, I forgot about the address. Set and string. Now, yeah, this is a very obsessive compulsive way of planning a class out. But if you wanted to like get really, really, really into it, this is something that you could do. If you really want to like upset your professors in the future, I would recommend turning in class diagrams with all of your simple programs. They would hate you for it. But hey, it's entertaining though. Okay, I'm a bad influence. Now, what's the last thing that I need in order to properly declare a class?
Responsibility.
Responsibility.
Or responsibilities.
Yeah. So in order to denote responsibility, I'm going to make a new box. And to make a new box, just go to two dashies. And then we just say, what's the responsibility? Responsibility of this would be, it's a data structure or class. I shouldn't say data structure. Class that stores information about the student. There you go.
You lost your divider between the attributes and the operations.
Oh, yeah, I did. Okay, let's just do this then. There we go. Good enough. Okay. Questions about that? Okay, now, one thing that we can do, we can use our student. So we can student, and we can say, we can define operations, or not operations, how should I say this? We can define different actions that different classes can take. So for example, a student can be enrolled, right? So I'm going to go student, and I'm going to say enroll, and let's say they can enroll in, say, computer science. And so you can say here, the student class, we can register an object of the student class into the computer science registry. We could also, if we wanted to, we could also do the same thing for, say, physics. And so this is a class diagram. It describes basically the structure of a class and the different actions that we can do, the different things that we can do with the class. So questions about that? Why is the student in a different color? I don't, what do you mean?
In your responsibilities block, the words
Oh,
the student.
yeah, that's just because I didn't, that's just syntax highlighting. That's because here, I'll make it there. How's that? Does that make you feel better, Emily? Okay. I'm glad that I can make Emily feel better. All right, cool. Any other questions?
Is there a way to stack the things it's registered to so it doesn't look goofy?
Yeah, so there is, let me just, that's a good question, actually. One sec. So you're not going to like this answer, but I'm going to give it to you this way anyway. So there is, if you go to plantUML.com, there are a load of different ways that you can change the layout of things. So let's see here. That's not what I was looking for. Better control layouts. It's Q&A. Layout elements. It's hidden diagram. There's okay. Real world. Here's a good website. I don't think I showed you. This was this is Real World Plant UML, and I would recommend having a look at this. They've got a bunch of different examples. That was a side note. You asked how can you change the layouts. Let's see here. You go to Stack Overflow. Okay. Yeah, so if you look at the, if you look in the forums, they've got a lot of discussions. I mean, I personally don't know off the top of my head exactly what, exactly how you can change that layout to make it look nicer. I'm sure that there's a, I'm sure that there's a easy way to do this, but I can't seem to find. I know what you want to do though. What does this do? Up and down. Let's play around with that for a split second here. I'm just going to try doing rather than just this regular arrow. Let's do, oops. Well, I didn't do anything. There we go. Does that make you feel better, Aiden?
Sure, we can go with that.
Yeah. So yeah, you can control, like what I've been doing is just like, if I don't like the way that it's laid out, I just change the length of the arrows and then just kind of let it decide. I'm sure that there's some sort of formatting way to do it, but I don't know it off the top of my head. Okay. So I'm going to go ahead and put this back the way it was. And save that. Okay. So there is that. Now, what time is it? It is 6:30. So the last thing that I want to do is I'm just going to go and show you some, like, because this is going to kind of wrap up plantUML. Most of the other diagrams, they kind of follow the same, because I've had a look at this. Most of the other diagrams follow pretty much the same pattern when it comes to defining them in plantUML. But what I would recommend is, if you want to use a different view, if you want to use a different view, if you want to use a different, say you want to use a use case, and maybe you also want to have a, I don't know, so you've got a, if you want to describe using a use case, and then maybe also describe your system using an activity diagram, right? They have examples of how to do each on both the plantUML.com website, and there's a, like I said, a good website called, I think I might have shared it with you. If I didn't, I'm going to have to do that. But Real World Plant UML. plantUML. And so this gives you some really good tutorials. Blammo. So this gives you some really good tutorials. So sequence diagrams, use case diagrams, class diagrams. There's a bunch of different ones here. So this is Real World Plant UML. I could probably share that in the Discord. I think I have Discord closed though, so I'm going to share it in the chat for right now. There we go. So now it's in the chat. Okay, so Real World Plant UML is a good one. Okay, so if there aren't any questions, I'll just show you some tips and tricks on how to do this, how to do some neat stuff in plantUML, and then we'll go from there. Okay. All right. Okay. Somebody said yes. Good. Now I can keep going. All right. So I'm going to. I know I can't minimize it. I swear I'm getting better with Zoom. It's just too many windows. I think I might need a third window. Okay. So I'm going to create a new file. I'm going to create a new file. Boop. And I'm going to call this cars.plantUML. Okay. We are going to make some diagrams about cars. Just trying to find my notes here. All right, got them. Okay. So this is just going to be kind of, and I'll publish these tutorials for you. I'll give you a copy of the code at the end here. But let's just go and I'm going to show you some tips and tricks on how to do plantUML. So first of all, let's go back. Let's do what's going on there. There we go. Let's go start UML, and end UML. All right. And so this is going to be a cheat sheet. Now, in order to do comments in UML, in plantUML, it's, say you want to do a block comment, / then a tick. And I'm going to call this my plantUML cheat sheet. And I'll give credit where credit was due. This was taken from, I'm just going to copy and paste this bit. There you go. This was taken from devhints.io/plantUML, adapted by yours truly. There you go. And cars. All right. So the first thing I want to show you is, well, how to do a just a single line comment, which is just using a tick. So methods. First thing I'm going to do is show you how to define a method in plantUML. So to define a method in plantUML, say that you have an object called a car, right? And what do cars do? What's something that a car can do?
Accelerate.
Accelerate. Yeah. Let's go with drive. Okay, so here's a method. Yay. So that's how you define a class and give that class a default method. You can also define a class, as I showed you this already. So alternatively, you can define a class by going class car and then defining the methods inside. So something that you might want to know about a car, for example, let's say you want to know the car's make, right? So that's something, oops, make. Now you'll notice something here. I have defined car before I made the class car, and plantUML interprets that correctly, right? So it knows that I'm talking about, when I've defined this class, it knows that I'm talking about the same class, both when I say car drive and when I say class car string make. It knows that I am talking about the same class. Now, another thing you might want to know about your car, say like the year, for example, and that's going to be an integer. Gotta turn off that autocomplete. And let's make drive a void. Yeah, so I'm just gonna go ahead and comment out this first one because now we've got a drive and a void drive, so we don't need both of those. All right, that should, there we go, that did it.
Why is your make and your year in 2 different formats?
What do you mean? Oh, the string there, oops.
No, I mean you have year, integer, string, make. You have them in the reverse order.
Well, because the make is going to be like Chevrolet or something like that. Oh, I see what you're saying. I see what you're saying. Yeah. Okay. That's because, yeah. Why did I do that?
Don't know. That's why I asked.
There. Does that make you feel better?
That does.
Okay. Good. I'm glad. I don't want you to feel bad. Okay. So now, thank you for pointing that out. Yeah. So now we can also, like I showed you before, we can declare. So this is going to be what a private looks like. This is what a protected looks like. This is what a public looks like. All right. So I'm just kind of putting together a little cheat sheet. So let's also separate. Oh, no, that's fine. We can do that. Okay. Now we can also declare things that aren't there. So for example, if we want to declare a static, right? So let's go static string ID. So give like the VIN number of the car. Okay. And so if you define it as a static, you'll see that it underlines it, right? So it knows that it's not going to change. Now, if it's an abstract method, we can go abstract void methods. And so you can declare abstract methods this way. And now they've got a little, they're italicized. I couldn't think of the word. It's italicized down there. Actually, I should maybe just to make it not look crappy, put this up underneath void drive. There you go. So that denotes an abstract. Okay. So that's pretty, I think, straightforward how to do that. So those are just really what I'm trying to show you here is just some nifty little things that you can do in order to make it look better. Now we can of course divide. We can divide things up using lines. I showed you that a little bit before, but you can like say class car, and I'm going to say these are separated by lines. The next line is a dotted line. And there you go. So we have a dotted line now. And then you can also do next is a double stroke. And there you go. Of course, we could just do 3 of those. I got a little bit excited there. There you go. So now there's a double stroke. You can also go use a plain line. You can also do a strong line. You can make headers as well. So yeah, there's some cool things that you can do with this. And I think it's cool because like I've already defined class car up here, and then I've again class car down here, and it automatically extends it. This is messy. I don't recommend doing this, but hey, it works. It's one of those weird squishy languages like HTML. I don't know. It's not a language. You know what I'm saying. Okay. Now I've already talked a little bit about associations. Now associations, once again, the associations are those arrows between different objects and classes, and they represent different things. So we've already talked about an extension. So another way of doing extensions, let's go. Extension. So you have the class car, and then you might have a small car extend the class car. Uh-oh, what did I do? Oh, I suppose I need that to be an arrow, don't I? There you go. So the small car extends the class car. Now I of course used the overloaders or the stereotypes before. Extend. But the open arrow means extend as well. So it gave me a little question mark there. All right. So another concept that we talked about is composition. And so composition means that something is composed of other classes. So, for example, a car, part of what it's composed of is an engine. So, composition. And we can denote a composition by going star dash dash. So, car has an engine. So that's what that means. And if I want to note that, I can say has a. There we go. Aggregation. So for example, if you have an aggregation of a car is cars. So cars is an aggregation of car. So that's what that little diamond means. This is it should be aggregate. Okay. Let's see, what else do we have? So you can also, you can also use dotted lines. I'm just gonna skip that. Now you also can denote relationships between things. Okay, so these are associations. I'll just put this up here. Now, relations. Okay, so for example, a driver has a relationship to a car, right? What's the relationship between a driver and a car?
Driver operates the car.
Yeah, the driver drives the car, right? Okay, so the driver, car, there you go, driver drives the car. Okay, so that's the relationship between the driver and the car. Now, you can say, like, for example, the car has an owner. And so the car doesn't own the owner, so I'm going to there you go. So now you see the owner owns the car. Okay. Now, of course, a car might have wheels. Hopefully it has wheels. Hopefully it has 4 wheels. And so there you go. So you can tell, see so the diamond means has a, right? So the diamond means has a, just think about it that way. The diamond means has a. The open arrow there is extends. So a small car is a type of car, right? So it extends car. And yeah. Yeah. Now, one thing that you might want to do when you're doing these diagrams is you might want to have little notes, right? You might want to have notes, and we can do that actually. We can add notes. So I'm going to go ahead and I'm going to, once again, go class car. We're going to call up car. And I'm not going to add anything to it, but what I'm going to do is I'm going to, actually, you know what? I'm not going to do that. Sorry. Some of you are just scribbling. I'm going to note left. And I'm going to say cars are cool. Oh, actually, that's pointing to wheels. So I'm going to say wheels are nice to have. There you go. So there's a note. Yeah, cool. Now you can also specify exactly where you want a note to be. So for example, note top of car. This is a car, beep, beep. there you go. And the final thing I want to show you are namespaces. So you can, for example, do a namespace. You can do a namespace client. And so a client is of the class driver. Okay. Ugh, dark olive green. Client is of the class driver. So we've defined the class driver right inside there. And car client dot driver owns. Oh, what did I do? Let's see here. Namespace client car client dot driver. What's it complaining about? Syntax error? I don't know. Is that a syntax error? I don't see it.
It's picky about spaces, so maybe it's the space after that arrow.
Yeah, let me, you know what? Here. Let's see if this will work. I need coffee. Yeah, I don't know what changed. All right. And so we defined on here, so we defined a namespace called client. Namespaces here, you can see are, if I can zoom in here, they are represented by this little, oh my goodness, stop. Although it looks like that arrow is the wrong way. Nope, it's the right way. It's just confusing. Yeah, so you have a namespace that includes driver. So the client, the driver is within the namespace client, and the client, who is also a driver, owns the car. Okay. Oop. There we go. So this is kind of just a little cheat sheet, and I'll publish this all for you guys so that you can do this in one of your upcoming assignment, or in your upcoming assignment here. So what I'm going to have you do for your upcoming assignment, and I'll write this up formally, and I know we're over by a minute now, sorry. But what I'm going to have you do for your assignment, your final assignment, is you're going to take your Pokemon, program that you did, and you're going to write it using UML in a few different ways. That'll be the major part of that assignment. I don't intend on making it a lot of work, but I'm hammering out the details. I want to try to include Petri nets, but I might not get to that in the assignment, so I might just have to teach that on Monday, but we'll see. But the last assignment's going to be doing these UML diagrams with your assignment. Is that cool? Got 2 people that like it. 3
Sounds
people.
good.
Yeah, makes sense.
Okay. Yeah, I just have to write it up formally, but I think what I'm going to do is I'm going to have you do some UML diagramming, and maybe have you do it in a couple of different, like have you pick one from each view, you know what I'm saying, and try to write it out from each view. So you'll probably almost certainly have to do a use case diagram. And then I would recommend just doing a use case diagram, a class diagram, and a why do I keep sequence diagram for your Pokemon game. But you can probably choose whichever ones you want. So I'll formalize it for sure. But that's what I'm thinking about right now. If you guys think that's cool. Yeah. All right.
Yep.
So I'll get that done as soon as I possibly can here. Okay. Okay. Well, thank you very much for your attention today. I'm sorry if this was boring, and I hope the fan didn't drive people nuts. It got pretty loud, even though I thought I shut it off, but whatever. Anyhow, So that's all I have for you today. I'm going to stop the recording here.